And welcome back to the afternoon session of CAT25 Part 2. And thanks to all of you who joined our ATV packed lunch. And special thanks to Noel G8GTZ for organising the ISS contact footage from ARIS for us. Our next presenter is Phil M0DNY, who first joined the ARIS UK operations team in 2016 to assist with AV production and has helped with ARIS HAMTV reception for UK and worldwide contacts since 2017. Since 2018, Phil has also worked on the QO100 and other Goonhilly Web SDR facilities and served on the BATC committee to maintain the club's web infrastructure. Well, later he'll be giving advice on filtering out adjacent band RFI on HAMTV. But first, Phil is going to give us an introduction to HAMTV on the International Space Station, talk about a typical ground station for reception, and show how they use a network of ground stations to support educational contacts. And a reminder that if you're watching this live, you can ask questions and make comments at any time on the BATC and YouTube chats. And now, welcome to Phil. Hello, Phil.
Good afternoon.
Good to see you, and we're looking forward to your talk this afternoon. Over to you.
Thank you. So I'm going to talk a little bit in this one, as Dave said, about HAMTV itself, the typical ground station that you might put together to receive it, and also about the TS merger, which is the software at the core of the network of ground stations. You saw a bit, you may have seen a bit in the ARIS contact there of the HAMTV in use on the contact last weekend. I'm going to start with an introduction of what is HAMTV. So the HAMTV transmitter, which is the box that we're actually talking about, is the blue box in this photo on the right with Samantha Cristoforetti. So this is a TV transmitter that runs in the 13 centimeters band, typically on 2395 megahertz. It has a couple of frequencies it can switch to as options, but 2395 megahertz has been the one in use since commissioning. It has about 2 watts output at the feed. I believe it's about 5 watts out from the unit itself, and then there's filters and coax in line, which push that down towards 2 watts, maybe even a little bit lower to the antenna feed on the outside of the module. It transmits 2 megasymbols per second DVB-S. Again, it can toggle to a different mode, but 2 megasymbols is the one that we use with half FEC. The inputs on it, this is quite an old unit, so it's NTSC analog video and an analog audio input. The NTSC analog video was designed for compatibility with the cameras on the space station that were there at the time. They are now in the minority. In fact, I believe there's only 1 camera left on board that has NTSC video out because they're all 4K HDMI units now. However, the ARIS has launched a HDMI to composite converter up with a test card generator that we're hoping they're going to press into service in the next few months once approval is completed. The encoding then on the DVB-S is also quite old. It is MPEG-2 video and MP2 audio. Within the roughly 2 megabits that we get through that DVB-S channel, we've got about 1500 kilobits of video, sometimes slightly more, and then the audio has been shrunk down to 64 kilobit per second. This is a reduction from what it used to. This is recent. This is a reduction from what it used to be in 2017. We used to have quite a lot of bandwidth on the audio. I think it was 250 kilobit or something, but that has been reduced to allow the video quality to be improved, and there is a noticeable improvement on that. This does have the advantage that the audio, the disadvantage that the audio, particularly with the noise in the modules, can be quite poor, and so sometimes the VHF can sound better. Next, I'm going to talk a little about the history of this transmitter module. So this project really starts with there was a fundraising campaign started from 2005 to raise funds for the S and L band antennas that were then installed on ESA's Columbus module just before launch in 2008. The HAMTV transmitter was then built to use these antennas for the S-band downlink. And in 2013, in August 2013, this was launched to the Columbus module on a Japanese cargo mission. It was then first commissioned in March 2014. There were a number of tests done at the time. And then in February 2016, we had its first use in a HAMTV contact. So this is the photo on the right here. This was one of the Tim Peake contacts that we did in 2017. And this was the first time that we'd had camera video during a contact through the HAMTV unit. That was thanks to Tim Peake, who was actually up for several hours beyond his scheduled bedtime, looking for the particular cable that was needed to plug the camera into the transmitter. But he sent Kieran an email late at night to say that he'd found it and that we were ready for HAMTV the next morning. Tim was then very keen to make use of the camera during the rest of his contacts while he was up there. And he also helped encourage other astronauts to agree to plug the camera in as well for their contacts. So we had Thomas Pesquet, Jack Fisher, and others started to make really quite regular use of it. Unfortunately, then in April 2018, the transmitter failed. You'll probably find some correspondence about this on the BATC forum, where we were trying to work out what was going on and looking for reports. But there was just no RF output observed from the transmitter. They tried rebooting it and all the normal steps, and that didn't work. Due to some of the budget limitations on the project to build this transmitter, there was only one ever built. So there was no spare, no engineering model. And so the only way to get this back working again was to bring that only transmitter back down to Earth. This isn't usual for ISS equipment. Usually it's far cheaper to build a new one and throw the old one out. But in this case, that same unit was returned to Earth, returned back to Kaiser Italia, who then, following repairs, and they made a couple of changes, including to the video bitrate. This went through approvals again. There were some more stringent RF requirements this time, which resulted in an extra filter having to be added to the transmitter output. And then it was relaunched to the ISS in March 2024. On relaunching it to the ISS, there was then an issue with how crowded the modules are getting nowadays. Someone had taken the space where it was originally installed due to a mistake in the space allocation. And so then there was quite a delay while that was worked out. But finally, thanks to ongoing efforts particularly from the ARIS USA team, in July 2025, it's finally installed in place in the Columbus module and powered on, and immediately came up with a very good signal. So on the use of HAMTV, as you may have seen in the contact video just now, the ARIS contacts historically use VHF, UHF, FM for voice, and actually we will continue to do this. This provides a good analog feel. You heard the astronaut's voice rising out of the noise as the space station comes over the horizon, and we find that really actually does add to the build up of the event. Although HAMTV has audio, we don't use it in contacts, partly because there's still a bit of a video delay on it that we believe is partly in the transmitter, although we do have some delay on the ground as well. The HAMTV is there to provide the additional facet of the live video alongside the voice questions. And as you may have heard, Kieran asking for a wave, and the kids do enjoy that, being able to wave to the astronaut as they wave back, as you can see in the photo there of another Tim Peake contact, the bottom one, with the primary school kids waving to Tim as he waves back. The astronaut can also do visual elements. You may have seen in the video at lunchtime, the stuffed toys floating around and the astronaut actually struggling to keep track of them. alongside talking on the radio. But they can also, of course, float upside down. Tim did this in one of our contacts where he very slowly floated upside down and then seemed to realize he was upside down and correct himself, which caused a laugh on the ground. The technical aspect as well, we've got the Yagis for the radio and for the VHF UHF radio side of things, and talking about that with the students or with the audience is a good way to bring the students into radio and amateur radio. And this provides another aspect to that. So we've got a slightly different looking antenna. We typically go with the dish antenna, I'll talk about later. And that's another technical aspect that we can talk about, and about how that works and about how this relates to the sky dish on the side of your house and that kind of thing. So the current transmission from the ISS, so the transmitter is currently on. I've seen some reception reports of it just this morning. The one major change from last time in 2016, 2017, if any of you received it then, is that sync detection has been added to the video input board. And this means no blue line and no audio hiss, which has actually made testing quite a bit more difficult. It's also digitally a lot cleaner, but it does mean that there's absolutely nothing to see changing or hear at all. So what you'll see is on the left, you can just about see that VLC window. It's just black. The aspect ratio last time was 4:3 incorrectly. That has now been fixed to indicate 16:9. So you'll see that VLC automatically goes to 16:9 when you pipe it in. The resolution reports as 352x480. We were a little worried about this, but the video quality actually looks really quite good from the contact last weekend, particularly quite good in relation to the MPEG-2 from 2017. And we still think there might be less horizontal resolution, but that combined with the up in bitrate means there's almost no compression artifacts. There's far less compression artifacts to be seen. And so this looks to be a good change. It comes out as 16:9. And so we're happy with this. The other thing to see, so the other key change that was made with the transmitter since 2017 is the program tables have now been added. So you can see in the VLC screenshot on the left there that there is HAMTV Program 1, publisher HAMTV Prog. The program tables and some of that related metadata wasn't there in 2016. It had been removed. And that prevented being able to receive it on a common satellite set-top box. They've now put that in, and it's now been tested that you can receive it on a standard satellite set-top box with the right setup. So that's a bit about the transmitter itself. The antenna that it's connected to. So I mentioned the L and S band antennas that are connected to the outside of the Columbus module. These photos are both taken Earth up, so upside down. That's just the original aspect of these photos. So on the photo in the left, you can see the beige panel or beige object that's underneath the orange arrow there, and another one to its left. These are the two L and S band antennas. The one that HAMTV is connected to is ARIS41, which is the one on the right, the one indicated by the orange arrow. Now, there's quite a long cable to this, and the cable also goes through a vacuum interface connector that is not an RF impedance matched device, and that's why we estimate that there's actually quite a low amount of power at the antenna. But as you can see, particularly from the photo on the right, there's no real blockage around it. The free space path to the ground is pretty good. Although we do occasionally see blockage, and we reckon it's from those solar panels because it's particularly on passes that are a little bit lower. Those solar panels will occasionally block certain ground stations from receiving it, and this is one of the things that kicked off the ground station network, and is part of the motivation behind the ground station network. The other thing that we can see here is that the antennas are about half a panel back from the nadir of the spacecraft, so the bottom of the spacecraft. This means that they're angled about 15 degrees backwards behind the ISS. And this is notable from when you're trying to pick it up at low horizon. If you have a high performance ground station, you're lucky enough to have a low horizon and you're waiting for it to come up over that horizon, you won't really, or in our experience, you won't be able to decode it until at least 15 or 20 degrees because you're still looking at it from effectively behind the module at that point. Once it gets to about 20 to 30 degrees, the signal strength picks right up. And then with a high performance ground station and a low horizon, it is decodable right the way down to the horizon on the descending side. So the pass is asymmetric that way. Moving over to talk about your typical ground station. So this is a rough block diagram of how we put together a typical ground station to receive HAMTV. So you obviously want an LNA to reduce your noise figure. You want reduce your system noise temperature, sorry. You will likely need a filter. I will talk a bit about that separately, a bit more about that and some of the experiences we've had. That filter probably wants to go before the bulk of your amplification for reasons I'll also talk about later. So another line amplifier, a cheaper, higher noise amplifier after the filter can work quite well. You can then optionally down convert, and there's a couple of down converters that are available for this. But also the mini tuner supports 2395 megahertz natively. Some of the SDRs support 2395 natively. So you don't have to, but if you've got a long coax run to your shack, then of course it makes the loss a lot easier to deal with. You've then got some kind of receiver that I put it into a PC here, but as I mentioned before, a satellite set-top box into a TV is also functional. And then a pointing mechanism. So typically we go with motorized pointing systems, for example, the Yaesu ASL systems. Some people have DIY systems. It is also possible to point it by hand, and that's something that GHGKQ actually used to do on a small dish. And that's totally possible. The main disadvantage is you can't do anything else while the pass is going on because you're trying to keep track of it. And so if you want to be able to test other things and watch the video or such, then it's useful to have some motorized automated system. On the pointing side, the big thing that matters here is the size of the dish. So there's quite a push generally for people to try and get the low elevation performance and to go towards the larger dishes in order to do that. So I'm going to assume here that you're reasonably aware of the satellite orbits and about how the spacecraft, when it comes over the horizon, is a very long distance away, but then that distance drastically reduces. So you can see here at so I'm starting here with a reference point of a 0.9 meter at 90 degrees elevation. An MER of 12 dB is easily achievable, which given we're using FEC half dBs, we only need 1.7. Okay, you want quite a bit of margin on that, but you still got 10 dB of margin over that at that point on a 0.9 meter dish. As you go down in elevation, that path length to the spacecraft dramatically increases, but you can see there at 20 degrees elevation, you've still got a bit of margin. I'd say that 2 dB is about the minimum you want. But you may not have a 20-degree horizon at your QTH. I certainly don't here. I'm at more of a 30-degree horizon here, particularly as the signal doesn't go nearly as well through trees and such. So even though you may be able to hear the VHF down to a lower horizon through the trees, you likely won't be able to receive the HAMTV through it, even with a large station. When it gets down to really low elevation, obviously you then do need something far larger than 0.9 meters. But as you get larger in dish, so the pointing requirements also become a lot more severe. So for a 0.9 meter, like that example in the photo there, you're plus or minus 4.5 degrees for the 3-degree beam width, which is quite achievable with a bit of care and calibration. I put there that the G5500, if you check the data sheet for it, it says plus or minus 4% on azimuth pointing, which is plus or minus 14 degrees, which is obviously way out of this. However, with good calibration of the pointing, lining it up well enough, you can achieve far better than that. And I achieve about plus or minus 2 degrees off a G5500 system. As you get down towards 0.6 meter, so you can with a 0.6 meter, you can still get off the top of my head anything above 45 degrees, you're going to be able to receive no problem. And that's plus or minus 7 degrees, which is actually quite a bit of the sky. And that's where handheld pointing, mounting it on a tripod, or even with a helical antenna of similar gain, you can quite easily hand point it within enough accuracy to be able to get a good decode. On the G5500 accuracy, alternatives such as SPID systems do exist with higher accuracy, but the cost really does start to go up quite a bit at that point. System noise figure, as we look at the RF chain, is something to keep aware of. So this pictured chain here, or the NOELEC special, as we've come to call it, is one of the ones that tends to get asked about as to whether it's suitable for use. So these three products are all available for NOELEC. You've got their wideband LANA LNA down converter, which has a 1.5 gigahertz LO, and that brings the 2395 down to about 900 megahertz. And that puts it in the receive range of the NOELEC RTL SDR, such as an RTL SDR V4 or such. And on the face of it, this looks great. However, the LANA has only a 12 dB gain, and the Ham It Down has no active gain in it and has a 12 dB conversion loss. And you're adding that to any cabling in the chain, because you're probably not putting the LNA, probably not putting the RTL SDR at masthead. And then the noise figure of the RTL SDR as well. And you end up with, even though you've got a 2 dB noise figure on the LNA, your system noise figure is actually well over 5 dB. So at this point, you're going to need an intermediate gain stage. Something with a higher noise figure is totally fine after the LNA, just to provide that additional gain before the loss of the down converter. Some down converters do have gain stages built in order to get around this, but the Ham It Down particularly doesn't. The example that I've given here, so where a 20 dB, 5 dB noise figure, which would be 10 or 15 pounds off eBay, reduces the noise figure by about 2.5 dB, which is the difference between a 1.2 meter and a 0.9 meter dish, just in how you set up your RF chain there. Unfortunately, adding gain does also cause some issues. So the particular problem we deal with is RFI. Now, this was quite an easily manageable problem back in 2016, 2017, when we were dealing with Wi-Fi, and Wi-Fi was the main issue. So there was a lot of making sure that when we went to venues, making sure that they moved all their access points off channel 1, so that we could then use some cheap filtering to remove most of the power there. And also looking out for any malfunctioning access points that were transmitting below 2.4 gigs, which it turns out to exist. This has changed slightly now in the UK, we now have the 4G band 40 owned by Telefonica. They purchased this in 2018. There was a good bit of consultation on it, which the BATC and RSGB were involved with. And you can see that on the left of this screenshot from Graham G8FXB, that the amount of solid power in that is significant. So whereas Wi-Fi was a bit of an intermittent signal, it would peak up on the SpecAN depending how much iPlayer people were watching. This 4G is constantly on. It's constantly there. It's quite a constant power envelope. However, it is a high power envelope. And you can see that's 5 dB per division there. The purple trace or pink trace, or it that you can see directly in the middle, is about a 6 dB signal to noise HAMTV. So it's a little bit weak, but not too bad. And that compared to the size of the 4G that you see here. This means that you need a high dynamic range in your system, because if you're padding down your system to be able to deal with that power from the 4G coming in, you can quite easily then lose HAMTV into the noise floor. This can be difficult. I've had to swap out a couple of amplifiers on mine because they haven't had enough output power without compression to be able to deal with this. And I've also been looking into filters quite a bit for this, and filters really is the first solution. And I'll talk a bit about that later. On the receiver side of things, we've got the mini tuner, which will be familiar to nearly all of you on the left. This is the ideal receiver for it. It works extremely well, copes with the Doppler, all this kind of thing. Since 2017, one of the new things is there's more software available for it. We've done some testing of the software around, and the best software that works the best is SatDump, which is pictured on the laptop on the right. So on the right, this is a photo of me receiving the ISS on a 0.9 meter dish in my back garden with a Hamit down and an air spy that you can see on the right there. And this is receiving a good, I think that was 11 or 12 dB MER with the SatDump software doing all the demodulation in software there. The software receivers do tend to be quite a bit more sensitive to overload and such, particularly from the high RFI levels. But with attention to that, they really do work quite well. Some other examples of ground station constructions here. So you've got the full dish on the left there that I was using the SatDump. So that's a 0.9 meter offset. I've got mounted sideways because it makes calibrating the elevation a lot easier. And that on a G5500 mount. The IK1 SLD Claudio in Italy at his Telebridge station has this unit, which I believe was part of the original batch of ground stations that were set up for HAMTV when it was originally launched. That's a 1.2 meter offset. You've got GHGKQ's first iteration of the hand-steered 0.6 meter there, and we used this quite successfully when we were first exploring HAMTV. You can just about see the spanner on the left hanging down that was used as a not a pendulum, can't remember the right word for it, but was used to measure the angles so that we could look that up against a printed out lookup table to see where we were meant to be pointing, and that worked quite well. On the right there, you've got at the other extreme end of things, this is the antenna that we have temporary use of for the contacts down at Goonhilly. This is a 5 meter S and X band antenna, which works very nicely. However, it still suffers from the blockage, so we still sometimes don't have signal at Goonhilly, where we do have signal with someone with a 0.9 meter antenna. And we believe that's due to blockage from the solar panels. So even with Goonhilly in the mix, there's still a requirement for more ground stations. On the operational side of this, so I've talked a bit about stations at home, how we use this at schools with the contacts. So for Tim Peake's Principia contacts, we use Knowles Land Rover here, which I believe Mike currently has, and this was set up outside the schools with the 1.2 meter ham design mesh dish on top. Noel has actually done a full talk about how he calibrated the pointing for this and his particular way of parking the Land Rover, assembling the G5500 in a certain orientation, so that he could make sure that this was pointed and set up in the typically 24 hours that we had from arriving on site to make this work. We then had issues with RFI, particularly from Wi-Fi, sometimes from malfunctioning Wi-Fi access points as well that were transmitting on directly 2395. These had to be tracked down, found, and pulled out within this 24 hours. And this is combined with all your standard portable station challenges that many of you will be familiar with, of finding out you've brought the wrong cables, your connectors come off the end of the cable, or trying to set this all up in the rain without anything getting too wet. And of course, although we all enjoy the technical challenges of this, the key thing here is for the participants and for the audience to get that HAMTV experience. So even if we've had a great time setting this up and solving lots of challenges in the setup, the key thing really is that we have that HAMTV experience for the audience at the contact. So the first way we did this was to get everyone, to get a bunch of ground stations to stream what video they were receiving to the BATC merger. Sorry, BATC streamer even. And Noel, GHGTZ, put together this page on the left of all the old Flash streamers put together. We assigned people a channel to go into. And then we would do manual switching of if X had a better, less glitchy stream than the current one we were looking at, then we'd close the current one, open the other one over the top of that, and switch between these. And this worked reasonably well, particularly when a ground station would totally lose it. We could then switch to another one that at least had a partial copy. But it did involve this manual work. We ended up sometimes with different delays between each of them, which could be a bit disorientating. And also we started to think about whether there was a better way of combining all the video information that we were receiving. And this is where Phil M0DNY, MI0VIM, started looking at the MPEG transport stream and working out whether we could combine this at an MPEG transport stream packet level. So MPEG transport stream, as used by HAMTV, has 188 byte packets. Some about approved 1 in 50 packets have a PCR timestamp. So this is generated from a 27 megahertz clock. But we can use this timestamp to synchronize the ground station feeds. We can have a 100 millisecond delay buffer that we wait for the streams to come in. And then we can pick one of the PCR segments from a particular station and output it. And then when the next PCR timestamp rolls around, pick the next segment from a ground station. And then we can switch between those ground stations based on the segments. It would be ideal to switch on a packet by packet basis, but the continuity counter that's used to clock the individual packets is both done per PID, so it's not uniform across the packets, and it also only has 16 values. It goes 0 to 15 and then loops, which means within a 50 long chunk, you can't actually uniquely identify the packets within that. So the only reliable way we've found to do it so far is using this PCR timestamp and switching within segments of that. So we then put the infrastructure together for this with the support of the BATC. And this is an example of it in use. This is on a contact by Jack Fisher. This was actually a contact being done in the States, but due to the orbit, the ISS was not over the States in waking hours. So we used a telebridge in Europe for the VHF, UHF, and we had ground stations in Europe that were receiving into the HAMTV merger. And then the venue that I believe was at one of the large mission control halls in Texas looked at the output of the merger, and they had the output of the merger there on the screen behind the questioning taking place. You can see on that screenshot there that we've got Goonhilly receiving. That was with our old 3.7 meter dish that we were using at the time. We've got my receiver that was down in Southampton. That was the offset 0.9. We had Jean-Pierre in France receiving, and we also had Wouter receiving in the Netherlands there. So this infrastructure was then also used for contacts with Paolo Nespoli and Thomas Pesquet as well, before the transmitter initially failed. Looking at the contact last week and what we used for that. So this on the photo is the picture outside of the venue. So the video that you saw was inside that tent that you can just see a slither of through the door there. South was down to the left of the photo. So the antennas, the VHF, UHF antennas are pointing north in this case. And on the right-hand side there, you can see the small 0.9 meter prime focus dish that I took along to provide the HAMTV. Now, this wasn't a high-performance ground station. The idea was that we had the high-performance ground stations at other venues that were well set up, have been well established, feeding the merger. And this really was a backup station for if we had internet issues, which we actually did at the start of the contact, and also to provide a technical thing on site to talk to the audience about as well. So looking at this structure of how I had things set up for that contact, you've got the typical components of LNA, filter, and line amplifier. I'll talk a bit more about the particular filtering I used in the next talk. Inside that equipment box next to the dish, I then had an RF splitter feeding both a mini tuner and a Pluto SDR. The mini tuner was the prime receiver chain for this, so I was running LongMind on a Raspberry Pi, which is the same software used in RIDE and in Portsdown, effectively the Linux version of the TwoTune software. This was feeding the TS merger along with all the other ground stations. But I also had a direct feed into a dedicated player as well. And this was so that if we had internet issues, then I had a totally independent route that we would be able to receive some HAMTV with. For playing this, I use a Raspberry Pi. This is Raspberry Pi 3 to play the MPEG-2 video, because the Raspberry Pi 3 is the latest Pi with an MPEG-2 hardware decoder. The MPEG-2 hardware decoder copes a lot better with the glitches. It just shows a glitch and moves on, unlike VLC and other players that tend to stall whenever they receive a glitch. And so I still find this is the better way to do this. I could talk more about that, but that's probably a whole nother talk in itself. This was feeding the two TVs at the front. The idea was I could switch between the two Pis. That was a case of unplugging one of them and plugging the cable into the other, which I did at the start of the contact due to the internet outage, but then we ended up swapping back, and I don't think any of it was output to the TVs at that time. In addition to the mini tuner receiver, I also had a Pluto SDR in there. The main reason for this was being able to see what was going on RFI-wise. We had a lot of issues with RFI, and being able to see the waterfall gave a good idea of what was going on there. So this is a screenshot of the reception at the Warwick venue. This is the Pluto SDR feed on the right-hand side, piping over the network, and then decoding on the local laptop. And then on the left-hand side, you can see GB4 RSS, which is the mini tuner feed from the venue, and also Goonhilly receiving. This was the blank pass at 7:30 a.m., the first pass of the day that we got up early and got in for. The display then, so this on the right was my desk during the color bars test pass, which was the next test pass, an hour and a half before the actual contact. On the left-hand side there, you can see the two Raspberry Pi cases. Those were the two media players, ready for me to swap the cable between them. I've got a preview of what they're showing on the left, and then I've got the laptop on the right with a remote desktop to the Goonhilly station, and you can see the merger in the background with all the stations active as well. Contributors to the Warwick contact, I'd just like to acknowledge that we had everyone who'd so far been qualified for contributing to the TS merger. So we had GHEKQ in Salisbury, we had Claudio in Italy, we had Leo in Czechia, we had the antenna lent to us by Goonhilly Earth Station in Cornwall, and then we also had Von Storch Engineering in the Netherlands lent us their commercial antenna as well. We did see some issues in the past last weekend. Particularly, there were more discontinuities, more glitches than I expected to see in the output. I've been looking at this more recently, and I plotted the PCR clock values. You can see that graph on the right-hand side, and you can see that although we've got a generally increasing line, there was also some erroneous values coming through as well, which really shouldn't be the case. And this fed into a player. FFmpeg coughs out errors when this happens and stalls the feed. And I think this also caused issues for the Pi players on site, because it wasn't a glitch so much, it wasn't lack of data as much as corrupt data. We were already filtering for having the correct MPEG header on the front. So this was errors in the data part of the MPEG, which would have really confused the player. In looking through this, I found that they were seen from SAT dump SDR receivers. And it was particularly notable. The first couple of glitches there are actually from the SAT dump receiver at Goonhilly. And the last set of glitches, lots of glitches there, are from one of the SAT dump receivers in Europe. And in looking into this, I found that SAT dump doesn't actually filter out the frames where Reed-Solomon reports that it's been unable to correct the errors. I understand that when you're building up a weather satellite picture or something, you want data in there, even if it's noisy. But for us, it's harmful to the merging process. So I'm currently modified a local version to filter out those, to filter out any frames where the Reed-Solomon reports that it's been unable to correct errors. And I'm currently testing that out with an option button added to filter out these. And then I'm going to try and get that merged into the upstream version. And then we will insist that people use this with this option enabled for contributing with SAT dump. Just a quick shout for volunteers towards supporting the TS merger for future contacts. Suitable receivers are Minitune or Portsdown, and also SAT dump. We are going to get that issue resolved so that contributors with that can continue to be involved. You do have to use a DVB push bit of software. This is the bit of software you can see on the screenshot in the right, on the screenshot on the left in the right. That takes the MPEG, it wraps it up into some batches, which avoids some internet router issues. And it also puts authentication headers on it so that we know who the transport streams come from. And as you can see, that's been quite useful in tracking down errors. We have an onboarding process where we'll talk to you about your internet connection. That tends to be the key bit that we care about. And to have a look at the error rate on your upload and help you with issues if you've got any issues there, so that your contribution, so that we can make the most of how much you're receiving with your antenna. And just a few links on here. I realize I'm running quite tight on time. We've got links on the streaming there for the main contacts. There's also a separate page with the TS merger output. You can see which stations are contributing there. We're still playing around with what data is available. There's signal to noise is not available from all stations. We're working on that. And we've got quite a bit of documentation we've been assembling on the wiki. There's several linked pages on there with different articles about ground station construction, typical issues, and contributing to the merger. And lastly, ARIS has set up a dedicated Discord server, to which there's a link there. You can also find it on search engine. And we have a dedicated HAMTV channel in there, where quite a few of us are often online and can answer any questions that you have. Thank you very much.
Lovely, lovely, Phil. Thank you very much for that. So much involved. What occurs to me is that you've been doing this for some time now, the UK ARIS team, and you're obviously still learning, still developing, still improving, even with all the technology that you've got. I must admit, I didn't know that you were using now a series of ground stations to contribute, but it does obviously allow for much longer contacts. But as you said, if the internet fails, you've lost it all. So you still have to put an antenna up there. We are running quite late now, and as there have been no questions so far on this, I think what we'll do is we'll round any questions up for the later session we've got with you after Jen's, and then if there's any questions then we've got rather more of an open-ended time. I just want to ask one quick question, if I may, though, Phil, and I think some people may be interested. Do you know what went wrong with the original transmitter that went onto the ISS? Did they actually say what had failed in it? Because obviously we're not used to having equipment up in space, and it's intriguing to know what failed.
I can't recall exactly off the top of my head. My recollection is that it was some faults with the encoder board. It's professional grade equipment, but it is not space grade equipment. It's not radiation hardened or anything. So my recollection is that it was something to do with a flipped bit in a flash memory somewhere, and so that left the encoder board unable to boot. And if I'm correct in that, then I've swapped out the flash memory in order to recover it.
Lovely. Okay, I have actually got one question. I will break my own rule and just ask you this because it'll all wrap up later on this afternoon. This is from Russ G4SAQ. Is it feasible to down convert to say 70 SEMS directly after the LNA and then filter it?
As long as your down converter, any gain stages in your down converter can cope with the large amount of power or RFI that you might have, then yes. Yeah.
Okay, lovely. Well, thank you very much indeed for this, Phil.